Hello, everyone. Once again, thank you so much for your time. Today, our topic for discussion will be still on signal representation. If you look through my previous video, I have used signal representation on ASK, FSK, and PSK. I use signal representation by constellation diagram. Today, I'm going to use Mary modulation, which easily means more than 4 level. Okay, at the previous video, I actually do 2 level, 4 level, ASK and PSK. Today, I'm going to show you a few more Mary modulation based on constellation diagram. This is my email. If you have any difficulties, please reach out to me. Before I start on today's discussion, I'd like to say thank you so much for those who send email to encourage me. And I also like to say thank you so much to Blog An, who leave all the comment that encourage me to push it on. Probably my channel is not that well received, but frankly, I already have met my primary objective. My primary objective to make this video is for my current student. Currently, I have a 24 student, and probably this will benefit my future student also. So please don't feel so bad. Okay, nowadays, I can't have a face-to-face lecture. Also no to face-to-face tutorial. I probably can only do face-to-face practical session. So therefore, after several so-called brainstorming, okay, I decided to use this YouTube, okay, to share with them what they expected to know rather than just over the Zoom session. Okay, so in short, please don't feel so bad that my channel is not that well received. Like what I mentioned, I have discussed through with my student. They feel that this video are simply let them understand the key concept. So no worry. So today, maybe for this video, okay, I will not ask anyone to so-called like and subscribe. Okay, so let me continue. Okay, if not, I won't have enough time to finish this video discussion. Okay, if you look through on my previous video, okay, I have used constellation diagram to describe 2 PSK or BPSK or 4 or QPSK. So this diagram here shows a constellation diagram on 16 PSK. Okay, by properly control the phase, okay, I actually can indicate which dot they are. So you can see from here, they have the constant amplitude of 5. And what I need to do is I adjust my phase. I actually can indicate different dot that I want to indicate. So this is what is 16 PSK. Next, okay, we have this 16 APSK, okay, which means a combination of amplitude and phase. Okay, again, from this diagram here, okay, you can see that I have a magnitude of 5 and a phase shift of 30. And over here, okay, I can have a magnitude of 2 and a phase shift of 180 degree. Okay, so from this diagram here, okay, I can so-called link to whichever dot, okay, by properly control the amplitude and also the phase. So this shows a combination of amplitude phase shift keying. Next is on 16 QAM. Okay, so by now you should have the idea, okay, I actually can control my amplitude and my phase, okay, I can so-called position in whichever dot that I want to indicate. So this is 16 QAM. Okay, and further, more points on 64 QAM. Okay, so I guess you already know how can I indicate individual dot. So it's still the same thing by controlling the amplitude and also the phase. So let me just show you 2 ways to represent a QPSK signal. So for my previous video, mainly I indicate this as the QPSK signal. The dot here having a phase shift of 0, this dot 90, 180, and minus 90 from here, or probably from here to here, 270. That's another way to represent a QPSK signal. So this is 45, okay, to indicate this dot, 45 degree. To indicate this dot is 135, okay, which is 90 plus 45. So therefore it's 135. And also I can have minus 45 and minus 135 to indicate this QPSK. Okay, they are the same, okay, except that their phase is different. Okay, so they also have the 4 level. Okay, so I just control the different phase to represent different dot. So this is a real life, how does a QPSK signal look like? Can you remember I showed you this diagram here, this 4 point here? So if you look, this is the first point, second point, third point, and fourth point. And what are all these lines? Okay, so these lines are so-called transition from one point to another point. Okay, you understand what I mean? So basically they shift from one point to another point. So therefore you have lots of line. Okay, and because this is a real practical measurement on a QPSK signal, so there are no ideal. So therefore you can see that instead of one solid line, there are multiple lines. And even right at the top, you mean those dot over here, okay, they are not exactly on the same position. So therefore, this diagram here show the ideal, does not show the ideal QPSK. So last but not least, okay, let's quickly do a comparison between QPSK and BPSK. Okay, you can see that by putting more dots onto the constellation diagram, okay, I can actually have higher throughput or higher data rate. Okay, so you will think that ideally I should put as much as possible, as much dot as possible onto a constellation diagram. However, there is a disadvantage if we are going to put more and more dot. Okay, so these slides here, I'm going to share with you what is the disadvantage when we actually put in more and more dot onto a constellation diagram. Okay, let's take a look on this QPSK here. So these are the 4 dots, okay, the blue, the yellow, the green, and the red. So these are the 4 dots that indicate the different message. And let's say if you receive a black color dot over here, okay, so this is the dot that you receive, then you have a problem. Should I put this black dot into the blue dot, or should I put this black dot into the green dot? So you may have some dilemma, okay, so where this signal should be. So you have this dilemma. So over this BPSK, instead of 4, I actually have only so-called 2 level. So it's either green or blue. And again, let's say that I have this error of 45 degree here. And from this decision making, I'm quite confident that this black dot actually belongs to the green. Can you see it over here? So this is the so-called the disadvantage when we actually put more and more dot. We are less tolerant to noise. If any discrepancy, okay, I may have issue to decide which this dot supposed to be as shown over this QPSK. Can you imagine the first diagram that I show it to you, 16 PSK, you probably have even had a harder choice to decide which dot they actually supposed to. Okay, so with this, I'd like to end my video. Thank you.